Hello, my name is Russell and my partners for this project are Kavish and Siobhan. Today I'll be looking at and giving a detailed explanation on an electronic device, the fire alarm. Now I'm sure that most of you have heard of what a fire alarm is, but in case you haven't, a fire alarm is a simple device with a sole purpose, to scream when there's a fire. And despite how simple it is, it makes our world a much safer place to be in because without them, a lot more of us would be dying in a fire. Yeah, they're pretty important. Along with the fire alarm's simple purpose, fire alarms are also quite simple in terms of electronics. Here is what a simple fire alarm circuit looks like. Let's break down the components of this circuit. From here, we see that there are 6 important components. Yeah, you hear that, magnetic strips? You're not important. Anyways, aside from those, we have a bunch of resistors, a 9-volt battery, a power diode, an LED, a transistor, and a thermistor. A resistor is an electrical component with 2 terminals. Its job is to reduce electrical signals, mostly voltage. Hence, if you use one, the current remains the same. Our next component is the battery. Batteries are quite simple. Their job is to supply DC power. The one in our fire alarm is outputting a constant 9 volts. Next, we have diodes. Diodes have a few uses. It can convert AC current into DC current, which we don't need here. They can also divert the direction of power and ensure that all the electrons and electricity flow in one direction. This is important because we don't want the circuit taking shortcuts or things could go wrong. After diodes, there's LEDs, which are light emitting diodes. They are diodes that emit light. Who would have thought? Another component we see here is the transistor. Now, transistors are a bit more complex than these other components because they have more than one terminal. They can act as switches. B can pass through to E at any time, but C can't pass through to E when B is off. Think of it like a transistor is a switch between C and E, and when B gets power, the switch turns on, and C and E closes the circuit. They can also amplify signals coming out of E. And finally, we have thermistors. Thermistors are resistors that can vary in resistance depending on temperature. There are 2 types, and the one used in this circuit is a negative temperature coefficient thermistor, meaning that as the temperature increases, the resistance decreases and lets more electricity through. At room temperature, the thermistor has very high resistance. Let's look at how this thing works now. Starting from the battery, the electrons move to 2 places. They can go through the LED and get stopped by the transistor, or they can go to the thermistor. When the temperature is low, the thermistor has a very high resistance and blocks the current from passing, and the circuit is broken. However, as the temperature increases, the thermistor eases the resistance and the electrons flow through. Let's ignore the bottom part for now and we'll assume all the current flows right. The current goes to the transistor and the transistor opens and allows the cut-off electricity to flow down. The new circuit is now closed, and to alert everyone of the urgent situation of a fire, a little light turns on. A silent fire alarm. That sounds like one of the most depressing things on the planet. Anyways, back to the circuit. Although I said to ignore the bottom part, it doesn't mean it's useless. If that part didn't exist, the current running through the transistor could be amplified and overload the circuit. Kavish, I think we get the point. Now, the purpose of this little bit down here is to split the current and route it back so it completes the circuit, and now we have returned to the cell. So now that we've explained the circuit, we can discuss how we can modify it. You could create the circuit in many ways with many different results. If you wanted your fire alarm to not false trigger on a hot day, adding more resistance would make it harder to set off. And if you wanted to detect from another source, replacing the thermistor with a light-dependent resistor will turn on the alarm when light is detected, turning your boring old fire alarm into an alarm clock that's timed to the sun rising. Some of the safety measures used in this circuit are resistors that limit the voltage, so that it doesn't overload any of the key components. Additionally, the entire bottom bit is also a current limiting feature, so that nothing overloads. And for the final part of this video, we can talk about applications. Alright, what would we use a fire alarm circuit for? I mean, well, if only there was a name for an alarm that triggers when there's a fire. Oh well. Supposedly, a fire alarm circuit can be integrated into a large machine that's prone to heating up and could catch fire. It saves having to install a full fire alarm in there, and oh, that's the name I was after. They're mainly used in fire alarms. A key difference should be pointed out though. In more advanced fire alarms, they use chemical isotopes instead of a thermistor. So, in conclusion, today we looked at fire alarms and the basic circuit. We looked at each individual component and established how they work together to make the full circuit. In past that, we explored the safety measures and how we can modify the circuit and how it's applied in the modern day life. A fire alarm is truly a useful device to make sure we all aren't killed in a fire.